Hi everyone, I welcome you to the presentation of this lecture on resistor color coding. Okay, so the resistance of a resistor can be determined by calculation, measurement, as well as using color code. So my interest here is how to determine the resistance of a material using the color code. Okay, so below are the color codes for fixed resistors and their significant figures. So you are supposed to know this. So this one is a 3-band resistor. Bands are these colors. So you'll be able to know the value of a resistor from those colors. So for a 3-band color code, the first color represents the first digit. The second color, that is from your left, represents the second digit. And the third color, this one is representing the multiplier. So this one is a value for the multiplier. Therefore, a 3-band resistor will have the first digit, second digit, as well as a multiplier. We go to the 4th-band resistor. So for a 4th-band resistor, you've got 4 colors. The first color representing the first digit, second color representing the second digit, third color, this one is representing the multiplier, but this time around it has a 4th color. A 4th color is representing a tolerance. So if you have a 4-band resistor, just know the last color there, the 4th one, is representing the tolerance. You go to the 5th band. So for the 5th band resistor, you have 5 colors like that. So the first one is representing the first digit, the second one is representing the second digit, the third one is representing the third digit this time around, the fourth one is the one which is representing the multiplier, and then the last one, the 5th one, is representing the tolerance. Okay, and then you go to the last one, which is the 6th. So for a 6-band resistor, it has got 6 colors, and they're in that order. The first, the second, and the third, these are the digits. The fourth is a multiplier. The 5th is a tolerance, but this time around it has a 60th band. The 60th band will tell you the value of the temperature coefficient for such a resistor. So you're supposed to know how these colors are aligned in that table and their values. Once you know that, then it will be very easy actually to tell the value of a resistor using color coding. So let's look at some examples on the next slide. Okay, so we look at some examples. So determine the resistance of the following color codes given below. So you've got those given color codes. Different combinations. We've got the 3 color code, we've got the 4 color code resistor, 5, as well as the 6. So let's look at the solutions. Okay, so you're supposed to know this, of course, their position in the table, value of the digit, multiplier, tolerance, as well as the temperature coefficient, if at all it has, like for a 6. Okay, so we start with the first one. So for the 3-band color code, we know that the first one is a digit, the second is a digit, the third one is supposed to give us a multiplier. So if you look at gray there has got a digit of 8, so you give it 8 there. You go to brown has a digit of 1, you give it a 1 there. And then you go to brown, which is the third one. So brown being the third one should be a multiplier. So if you look at brown there, the multiplier is 10 ohm, so you have 10 ohm there. Therefore the value for this resistor is 810 ohms. We go to the second one. So the second one is a combination of orange, white, blue. So we know orange as the first digit has 3. This is the 3 we are having there. We go to white. White has a digit of 9. Blue should be a multiplier. For blue, the multiplier is 1 mega ohm. So we have 1 mega ohm for blue there. And then we have silver, which is a tolerance of plus or minus 10%. Therefore, we are having that value there as the value for the resistance for such a combination. We go to 5 color code. For a 5 color code, we have red being the first digit. You give it a value for red, which is a 2, as it can be shown there. Then we have a white. White has got 9. You give it orange, a digit for orange is 3. And then you go to yellow. Yellow this time around for a 5-band should be a multiplier. So a multiplier for yellow is 10 kilo ohms. You give it 10 kilo ohms. And then blue should be the tolerance. The tolerance for blue is plus or minus 0.25%. Therefore, you are going to have 2930 kilo ohms plus or minus 25% as the tolerance. So this is the value of that resistor. Then we go to the last one, which has a combination of brown, blue, green, yellow, red. So we know the first one should be a digit, the second one a digit, the third a digit, the fourth should be a multiplier. For yellow it's 10 kilo ohms. The fifth one is the tolerance, of course, and then the last one is the value for the temperature coefficient. So read as a temperature coefficient of 50. Therefore, the actual value for the resistance is that. So this marks the end of my discussion on resistor color codes. Thanks for watching.